Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss the solution of n-queen problem using bits, right? So in this problem we are given a number n and we are having a n cross n chessboard and we have to place n queens in that chessboard in such a way that no two queens can kill each other, right? So the condition is written as queen kills at distance in all 8 directions, right? So a queen can kill another queen in all the 8 directions, right? So we have done the same question in our backtracking also, right? So in that question, in that module, we are solving this question using recursion only. So in this we are using the concept of bits, right, in order to reduce the complexity, right, in order to reduce the time and space required, right? So what is the problem? We are given, for example, we are given 4 queens, right? So we have to place these 4 queens in a 4 cross 4 board, right? So there is a 4 cross 4 board, right? So we have to place 4 queens here, right? So first queen can be placed here, right? So I can place the first queen here. Now the second queen can't be placed here. Why? Because it is in the same row. Now since I have placed the queen here, now I can't place any other queen in this row, in this column, in this diagonal, and in the reverse diagonal, right? So I can't place the queen in any of these directions, right? So I can't place the second queen here because it will be in the same column. I can't place in any of these cells because it will be in the same row. I can't place here because it will be in the same diagonal. Now I can place the second queen here, right? Next is the third queen. I can't place the third queen in this because it will be in the same row. The third queen can be placed here, but it will be in the same column. So this queen can kill the third queen. So I can't place here because it is in the same diagonal. I can't place here because it is in the same column. I can't place here because it will be killed by this queen in the same diagonal, right? So what will I do? Now I can't place the third queen in any of these configurations. So I will backtrack and I will change the position of the second queen. Now I can place the second queen here. Again I can't place the third queen here. I can't place the third queen here. Why? No, I can place the third queen here, right? So it will be safe. Next is the fourth queen. I can't place the fourth queen here because it will be in the same column. I can't place the fourth queen here. I can't place it here. I can't place it here. So what I have to do? I will have to backtrack. Now I can't place the third queen here. I can't place it here. So again backtrack from here. So there is no any other possibility for the second queen. So backtrack from this also. So next is that we can place the first queen here. Now I can't place the second queen in any of these cells because it will be in the same row. Next, the second queen can't be placed here. It can't be placed here. It can't be placed here, right? Next, the second queen is safe here. Next is the third queen. I can place the queen here, right? Because it is safe in all the 8 directions, right? Next is the fourth queen. I can't place it here. I can't place it here. I can place the fourth queen here, right? So I am able to find a possible configuration. If I write the row and column numbers, so the solution is given in this format, right? So let me take it to the whiteboard. So first is the row number, second is the column number. So for this queen the row is 0, column is 1. For this queen, the row is 1, column is 3. For this queen, row is 2, column is 0. For this queen, row is 3, column is 2. Right? So we are able to find a possible configuration to place all the 4 queens in the chessboard in such a way that no 2 queens can kill each other. Right? So now it is possible that there exists some other solution also, right? For example, for this problem there is another solution also. So in order to find another solution, again we have to backtrack, right? So what we will do, we will backtrack from here. So we will place the third queen in here, but we can't place it here. We can't place it here. We can't place it here, right? Again we will backtrack. Now we can't place the second queen in any other cell, so we will backtrack from this. So next position for the first queen is this, right? So again we will check the queen position for another three queens, right? So one possible solution is this, another possible solution is this one, right? So next queen can't be can be placed here, right? It is safe from all the 8 directions. Next queen can't be placed here, can't be placed here, can't be, it can be placed here, right? So it is safe from all the 8 directions. Next is the fourth queen can't be placed here, it can be placed here, right? So this is another possibility: 0 2 1 0 2 3 and 3 2 3 1, right? So this is the another possibility to place all the queens such that all the queens are safe, right? So now what we have to do, we have to find these possible configurations, right? So what we are doing, we are placing a queen and we are checking that is it safe from all the 8 directions. Now if I place a queen here, now I have to check in all the 8 directions, that is in this row, in this column, in this diagonal, in this reverse diagonal, right? So if any queen is placed in any of these 8 directions, then I can't place the new queen here. For example, if a queen is already there in this cell, now I can't place this queen here. Why? Because this queen can be killed by this queen, right? So in order to place any queen, I have to check in all the 8 directions, right? So this is the problem. We have to find all the possible configurations. In order to find the configurations, what we have to do, we have to backtrack, or we have to perform backtracking, right? Now we are performing we have solved the same problem in our backtracking module. In that module we are using the recursion, right? And we are, while placing a queen in a particular cell, we are checking in all the 8 directions, that is whether it is safe to place a queen in any possible cell. Another way to solve this is, we will discuss that. Now we have to check four conditions, that is it is safe to place a queen here, that is by checking the row, by checking the column, by checking the diagonal, and by checking the reverse diagonal, right? But now it is sure that if I place a queen here, I can't place any other queen in this row. If I place a queen here, I can't place any other queen in second row. Now the size of the board is n cross n and the number of queen is n. Now it is sure that only one queen can be placed in any particular row. So what we will do, when I place a queen here, now I will move to the next row. Why? Because I can't place the queen in any of these cells, right? So when we place a queen in any of the cells, we will move to the next row. So we will move in the next row. Now there is no need to check the row condition here. Why? Because only one queen can be placed in any specific row, right? So we don't need to check the condition for a particular row, that is it safe to place a queen in a particular row. Why? Because when we place a queen in any row, then we will move in the next row, right? So we have to check the conditions for column, for diagonal, and for reverse diagonal. Right, now it is very easy to check the condition for column. So another way to check these conditions are by using the arrays. So we are using an array of n size. So this is the column number. So if I place a queen here, then I will mark this, all these values are false. So I will mark this cell as this column as true, which means that now I can't place any other queen in the first column, right? So next, if I place a queen here, I will mark this column as true. This means that I can't place any other queen in this column. So while placing a particular queen, we will check in a particular column only, that whether is it safe to place that queen in this column. So if the value is true, this means that we can't place the queen there, right? So this is another possible way. For diagonal also, now in order to check the condition for diagonal, so we can check the value of r plus c, that is row plus column. Now for this cell, the value of r plus c is 0. For this it is 1 plus 0, 1. It is 0 plus 1, 1. 0 plus 2, 2. 0 plus 3, 3. 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. Right? Similarly, 2, 3, 4 and 2 plus 3, 5. Next is 3, 4, 5 and 3 plus 3, 6. So these are the possible columns. Sorry. So these are the diagonals. So this is this by using this, that is r plus c, we are able to mark the diagonals, right? So the number of diagonals is 7, right? Now this is what we can find the number of diagonals by this, that is 2n minus 1. Now n, in our case n is 4, so 2 into 4, 8 minus 1 is 7. So we are having a total of 7 diagonals, right? So we will make an array of size 7, 3, 4, 5, 6. So mark this. So now if I place a queen here, then I will mark this diagonal as 2. That is the diagonal number 2 is marked as 2. Now this means that I can't place any other queen in this particular diagonal, that is diagonal that is marked as 2, right? Again, if I place a queen here, then I will mark the diagonal 6 as 2. This means that I can't place any other queen in this diagonal, right? So for diagonals we are using r plus c value, that is this value is used to mark the diagonals, that is to identify the diagonals, right? Now, and the total number of diagonals are 2n minus 1, right? Similarly, in case of reverse diagonals, the total number of diagonals are 2n minus 1, right? For this also 2n minus 1. Now, in order to identify the reverse diagonals, what we can do, here we are using r plus c, here we can use r minus c. Now you can see that the value of r minus c is same for a particular reverse diagonal, that is for this 0 minus 2, 2. For this 1 minus 1, sorry, reverse diagonal, that is this this one, right? So here 0 minus 1 is 1, 1 minus 2, 0 minus 1 is minus 1, 1 minus 2 is minus 1, 2 minus 3 is minus 1. So for a particular reverse diagonal, the value of r minus c is same. For this diagonal also 2 minus 0 is 2, 2 minus 1 is 3 minus 1 is 2, right? But if I found it by using r minus c, I am getting the negative values, but in array I can't use the negative indices, right? So what we can do, we can add another component, that is the length of the board, that is n minus 1 to this, that is r minus c plus and length of the board minus 1. Now if I use this component, then this will give me all the positive unique values of all the reverse diagonals, right? So for example, let's calculate the value for this diagonal, right? So this is 0 minus 0 plus n minus 1, that is plus n is in our case n is 4, so we have to add a component 3 to all the r minus c values, right? So 0 minus 0, 0 plus 3 is 3. 1 minus 1, 0 plus 3 is 3, 2 minus 2, 0 plus 3 is 3, 3 minus 3, 0 plus 3 is 3, right? So similarly for this diagonal, 0 minus 3 is minus 3 plus 3 is 0, right? So this is 0. 0 minus 2, minus 1 plus 3 is 2. Similarly 1 minus 3, minus 2, 1 minus 3, that is minus 2 plus 3 is 2, right? So this is another reverse diagonal, right? Right, so in this way, by using this r minus c plus n minus 1, we are able to mark our reverse diagonals uniquely and with the positive indices, right? So let me mark the diagonals. By using this, these are the row values, these are the column values, right? So the value is r minus c plus n minus 1, that is r minus c plus 3. Now this is 0 minus 0 plus 3, 3, and this is 1 minus 1, 0 plus 3, 3, 0 plus 3, 3, 3 minus 3, 0 plus 3 is 3. This is 0 minus 1, that is minus 1, plus 3 is 2. This is also 1 minus 2 is minus 1, plus 3 is 2. This is also 2 minus 3, minus 1 plus 3 is 2. Next is 0 minus 2, minus 2 plus 3 is 1. This is also 1, this is 0. Similarly, you can find out the values for this. You can verify this from this value, that is 3 minus 1, 2 plus 3 is 5, right? So we are getting our reverse diagonals. This is first, fifth and sixth, right? So we can use an array of 2n minus 1. Here also the number of diagonals are 2n minus 1, right? So there are 6, 0, 1, 7, sorry, 4, 5, 6, right? So if I place a queen here, then I will mark the third reverse diagonal as true. Now this means that I can't place any other queen in this particular diagonal. So if I am going to place a queen here, then I will find out that the value in the reverse diagonal array is 2. This means that I can't place the queen in this particular cell, right? So this is another way to find out that is it safe to place a queen in a particular cell or not, right? But in this case also we are using an extra space, that is we are using the arrays, right? Now we can do the same operation by without using any extra space by using the concept of bits, right? So in the place of array we are using bits here, right? So let's understand this by using an example. So let's take an example of 5 cross 5 board. We are going to use the same operation, that is same approach, but instead of using arrays we are using bits. That is we are going to solve this problem without using any extra space, right? So this is 0, 4, this is 0, 1, 2, 3, 4, right? So we will check it for column, for diagonal, and for reverse diagonals, right? We don't need to check it for rows, because there is only one possibility that we can place only one queen in a particular row only, that right? So if we place a queen in a row, then we will move to the next row. Why? Because we can't place any other queen in that row now, right? Right. 1, 2, 3, 4, 5, right? So first is the diagonal. So instead of using arrays we are using bits here, right? So these are the bits for the particular columns, right? So if I place a queen here, then I will mark this bit, that is bit number 1 as 1. Now this one is showing me that I can't place any other queen in this particular column, in the first column, right? Similarly, if I place a queen here, then I will mark the bit at the third position as 1. Now this means that I can't place any other queen in the third column, right? So by using bits only, without using any extra space, that is without using the array, we can find out that whether it is safe to place a queen in a particular column or not. Similar is the case for diagonal. 1, 2, 3, 4, right? So our diagonals are 0 plus 3, 3, 1 plus 4 is 5, right? So let me write the values for diagonals. The way to find the unique identity for diagonals is r plus c, right? So this will be our first diagonal, this will be our second diagonal, next 3, 4, fifth, sixth, 7, let me write the values here. 0 plus 0 is 0. 1 2 3 4. 1 plus 0 is 1 2. 1 plus 2 is 3 4. 1 plus 4 is 5. 2 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 3 4. 3 plus 2 is 5. 3 plus 3 6. 3 plus 4 7. 4 5 6 7 and 8, right? So these all are our diagonal, that is first diagonal, second diagonal, third diagonal, fourth, fifth, sixth, seventh and eighth, right? Similarly, the reverse diagonals will be like this. The way to find the identities are r minus c plus board length of the board, that is board length minus 1, right? So we will get the values like this. Right, so these all are our reverse diagonals. Now in this case also we are going to use the bits instead of the arrays, right? 7 and 8, right? So this is our 0th bit, so we will use the bit here, that is we are using only a number, so also these are our bits. Now similarly, like the columns, if I place a queen here, right, so what I will do, I will mark the fourth bit as 1, which means that I can't place any other queen in this particular diagonal. Similarly, if I place a queen here, then I will mark the fifth bit as 1. Now this means that I can't place the any other queen in this particular reverse diagonal, right? Similarly, if I place a queen here, I will mark this bit as 1. If I place a queen here, I will mark this bit as 1, right? So what we have to do, if we place a queen in a particular cell, then we will mark the particular bit in the column as 1, we will mark the particular bit in the diagonal as 1, and we will mark the particular bit in the reverse diagonal as 1. Next, when we are going to place the queen in any other column, we will check that the particular bit for column, for diagonal as well as for anti-diagonal. If that particular bit in any of the three cases is 1, this means that we can't place that queen in the particular cell, right? So this is the way we are going to implement this n queen problem using bits. Instead of the arrays, we are going to use the bits, right? So initially all the bits are set as 0, right? For column also, for diagonal also, and for reverse diagonal also. All the bits are initially set to 0, right? So if you haven't watched the video of this problem in the backtracking module, then I strongly recommend you to please watch that video first. After that, you will find this problem very easy to implement using bits, right? So let's execute the code for this. So we are given 3 bits, that is column, diagonal and reverse diagonal, all are set to 0 initially, right? So what we have to do, now we are given a row value. If I place a queen in a particular row, now in next time we are going to increment this row, that is, this means that we can't place any other queen in that row now. Why? Because we can place in one row we can place one queen only, right? So we have to check in the columns. Now if I am in this row, now I have to check in each column that whether it is safe to place a queen in any of the columns. So we will check from columns. Board is given. Right, now we have to check that whether it is safe to place a queen in a particular cell or not, right? So if we will write this condition afterwards, if the condition is true, that is we can place a particular queen in that cell, then we have marked that cell as true, row and column as true. Now this is marked as true. Now next, after placing a particular queen, we will move in the next row and add the next queen, right? So we will call this function again, right? The board will remain same. The row will be incremented by 1. That is, the next queen can be placed in the next row now, right? Next is calls n diagonal and r diagonal. In the answer so far, we have to add the row value plus 1 hyphen is there, plus the column value. After there is a comma and a space, right? So in the answer so far, the row and the column value will be added. Next, we have to backtrack also, right? In order to find the another possibilities, right? So in order to backtrack, again mark this value as false, right? Now if I place a queen in this particular column, I have to check that if the bit at this column is 0 or not, right? So if we have to check in this value, this is representing this bit, right? So calls is representing 0 0 now, 0 0 0 0. So if I place a queen here, I am placing a queen at 0th column, so I have to check at the 0th place, right? So in order to check whether a particular bit is 1 or not, so I have to check in the calls bit, right? Right shift the calls by the value, that is this value is representing the particular column, right? So firstly I am checking in the 0th column, that is whether I can place a queen here or not, right? So if the bit at this position in the calls in the number is 0, right? So if it is 0, this means that I can place the queen in this particular column, that is in this column, that is call column, right? Next, I have to check for the diagonal. This is for column. Next, we have to check for the diagonals. Now for diagonals, we have to check in the diagonal bit, right? So this is our diagonal bit, that is n diagonal. In n diagonal, 7 zeros are there, right? So I have to check that a particular bit, that is the diagonal in which I am going to place my queen, is that particular bit is 0 or not. If it is 0, this means that I can place the queen in this particular diagonal, right? So in order to find that a particular bit is 0 or not, and diagonal, check at the, now the position is represented by r plus c, right? So check at the r plus c value, that is row plus column. So if this is 0, this means that we can place the queen in that particular diagonal. The same condition is for anti-diagonal, that is for the reverse diagonal, that is find out that is the bit at the particular reverse diagonal. Now in order to find the position for the reverse diagonal, we have to use this formula, right? So right shift it by row minus column, board dot length plus 1, right? So if this value is 0, if all these conditions are true, that is the column is safe, the diagonal is safe, as well as the reverse diagonal is safe to place, then we will place the queen in that particular cell. Now if I place the queen in this cell, I have to mark this bit as 1. If I place a queen in this cell, I have to mark this fourth bit as 1. If I place a queen in this cell, I have to mark this 3 bit as 1, right? So if this is true, then we have to mark all these as. So in the column, so this will toggle the value present at the pole, right? So this will toggle the particular bit. That is, the bit is previously 0. Here we are checking that if the bit is 0, then it will toggle the bit, that is, it will set the bit to 1. Now the 1 is representing that I can't place the another queen in this column, that is the bit representing in this column, right? Next, same is for diagonal. Toggle the bit present at R plus C, that is row plus column value. Similarly for reverse diagonal. Row minus column plus length of board minus 1, right? Now after placing the queen, again we are backtracking, so again we have to toggle this value, right? So when I backtrack from this, I have to set this value again to 0. That is, toggle this value again. The value is 1 now. Toggle this again to 0. Also, if I backtrack from this, if I am removing the queen from this, toggle this value. That is, set this value. That is, this value again to 0. Right? So this will toggle the values again. Now is the base condition. If all my queens are placed now. That is, if I have reached the last row. We have to do what? We have to print our solution, that is the answer so far. Answer so far plus a dot is there. And return from here. Right, so this is our code. We are checking that in if I am going to place a queen in particular cell, then is this cell is safe for that queen. That is, this is checking that if the particular bit is 0 in the column bits or not. This is checking for diagonal, this is checking for the reverse diagonal, right? So if all the bits are 0, that is the column, the diagonal as well as the anti-diagonal is safe. No queen is present in that particular cell and diagonals, so I can place the queen there. So I am placing that there, and I am setting the values bits as 1. Now this means that I can't place any other queen in this particular column, right? So now I am checking the solution for the next queen. After finding the solution, I am backtracking by using this, right? So I am setting the bits again to 0, right? So this is our code. Let's try to run it. We are getting an error. Here I think we are missing the brackets. So whenever we are implementing any bit operation on the integer number, we have to put the braces, right? Otherwise it will be implemented for falsely by the compiler, right? So let me add the braces here, right? Here and here also, right? So whenever you are performing any bit operation on any integer, so always use the parentheses, right? So here I minus, here I forgot to put the plus value, right? So in order to find the reverse diagonal, the value is r minus c plus board of length minus 1, right? So row minus column plus board of length minus 1, right? Rest all is fine. 21. here code will come, right? So we are getting the correct output, right? So let's try to submit it. So our code is correct for all the test cases, right? So what we are doing, while placing a row in a particular cell, we are checking that whether that particular bit is 1 or not. If that particular bit is 1, this means that a queen is already there, present in that particular column, right? Similarly, we are checking for diagonal and for anti-diagonal, right? So if a queen is present there, which means that if the bit is 1, this means that we can't place this queen in this column now, right? So but if the bit is 0 here, right? So if I am going to place a queen here, if the bit is 0, this means that I can place queen in this particular column. So we will I will check for the diagonal condition. If the condition is true for diagonal also, that is the bit is 0 for diagonal as well as the bit is 0 for reverse diagonal, right? So this means that the queen is safe to place. So we will firstly mark these values as all these bits as 1, which means that now I already placed a queen here. So you can't place the queen in any of this column, diagonal or anti-diagonal, right? Next, I am placing the queen here. So I will call the next queen, right? So after that I am backtracking from this, which means that I am toggling the bits again, that is I am setting the bits again to 0, right? So what I am doing, I am checking that if the bits are 0 for column, diagonal as well as anti-diagonal, I am setting the bits to 1, that right? Next, I am placing the queen in that particular cell and I am following the solution for the next queen. And after finding the solution, I am backtracking from this. So I am unplacing the queen from that particular cell and I am setting the bits again to 1, right? So this operation will toggle my bit present at this position, at the call position. This operation will toggle my bit in this number present at r plus call position. Similarly for reverse diagonal, so I am toggling the bits again, that is the bits are 1, I am toggling it again, that is the bits are again set to 0, right? So this is the code. So we are implementing this solution in without using any extra space, and we are using the big of 1 space, right? So in order to find that a particular queen is safe to place or not, we are using a big of 1 solution, right? So if you haven't watched the video for solving this problem using backtracking, watch that video first, then you will find this video very easy, right? So I hope you understand the concept of finding the solution to place the n queens using bits manipulation, right? So I hope you like the video. Thank you for watching.